estimation, that's what we would use. So we can use the bisection method to estimate it even further, or more accurately. Looking at example 9 now, I'll go through an example. So we have use a graphical method to estimate any solutions to the equation x to the 4 take 2x take 12 equals 0. Okay, using our summary, rearrange the equation into the form p of x equals q of x. So how can we do that? I can say x to the 4 is equal to 2x plus 12. So in this case, p of x equals x to the 4 and q of x equals 2x plus 12. Right, next part, sketch the graphs of p of x and q of x with care. So before I go any further, to be able to sketch those points, I need to determine y-intercept, x-intercept, and any turning points. Okay, x to the 4, well that'll have a y-intercept of 0, an x-intercept of 0, and there's going to be a turning point at 0. For this one, our y-intercept is going to be at 12, our x-intercept is going to be at y equals 2 times x plus 12, so 0. Take 12 divided by 2, x equals minus 6. And there's no turning point because this is a straight line. Kind of just rushed through that a little bit. Now, the straight line has y-intercept at 12, yep, and x-intercept at minus 6. The quartic has so minimum turning point. Okay, because it's positive, going to have a minimum. Goes through 0, 0, and contains the points. So at 1, when y equals 1, x equals 1. At y equals minus 1, x equals positive 1. So what we can say is when y equals plus or minus 1, x equals 1. Okay, just a bit of a summary so we can have some points to graph the equation. And also at y equals plus or minus 2, we'll have a positive, actually it'll be 16. 2 to the power of 4 is 16. And that's plus or minus. Okay, so all I've done is just get some points in so I can draw them in a moment. Okay, so I've drawn in my axes and I've used a ruler and I've equally spaced them out. So once I've done that, we can start putting the points in. So I'll look at x to the 4 first. So we know it goes through 0, 0. And that's the turning point. We know it goes through positive and minus 1 and positive 1, so here and here. And when we go to 2, we go into 16. So if I say 1, 2, up to there. So there and there. Okay, and I'll try and sketch it as best I can. Okay, so you can kind of see how steep x to the 4 is. Quite steep. Now the other one should be pretty straightforward. Is a straight line. So we've got a y-intercept of 12. So going up 12. So in here, and we have a x-intercept at minus 6. So in there. and then just connecting the dots as such. So what do we notice? Well, with first thing, we've got two x-intercepts, or two intercepts. Okay, so because the equations have two intercepts, this initial equation that we had is going to have two solutions, or two x-intercepts as well. Next part is to find what those intersections are. So this point here looks like it goes through the point 216, okay, which is what we worked out here. It just looks like it goes through that point. That's a good estimation. So that's one. Our next one is this one down here. Now, from the graph, we can say it's about 1.7, 1.8. Okay, and on the y, it goes through that one there, so about 7. Okay, so they're the 2 points that we can estimate. So our estimation from the graphs say that this equation is going to have solutions of x equals 2 and x equals, that should be minus 1.7. So there are two solutions for the x coordinates on this graph, or x-intercepts. Again, we can get a even closer method estimation by using the bisection method with these points, if we wanted to, but I'm not going to go through that. So that's estimation using interceptions of two graphs to find the solutions to the equation.